Thank you. We continue with our next speaker is Roberto Alvarenga from the State University of Sao Paulo. He will talk about on Hecke modifications and parabolic structures. Thank you.
Okay, thank you. First of all, let me thank the organizers for having me here. It has been 7 years since my last time in IMPA. It's always very great to be here, especially in this occasion of Frank's 60s. So my plan for this talk is to tell you about a correspondence between Hecke modifications and parabolic structure, actually quasi-parabolic structures on a vector bundle. So the goal of the talk is that I want to tell you about how I can go from a Hecke modification of a vector bundle to a quasi-parabolic structure, and how can I go back from a quasi-parabolic structure to a Hecke modification. So to put everybody in the same page, I want to define what's a Hecke modification. I work over a curve over any field. You can take here the complex numbers if you want, but can be any field. Given two vector bundles and a closed point on the curve, I'm going to say that E prime is a Hecke modification of E if of weight R, if there is such exact sequence. There are other equivalent ways of defining Hecke modification, but I think this is more, I mean, it's a simple way to define Hecke modifications for those that have never seen the definition. I should say that Hecke modifications of vector bundles is also known in the literature as Hecke transform or elementary transformation. These are all the same concept. And let me introduce a couple more notation. I'm going to denote by this double crochet here by the isomorphism class of Hecke modification, which means take isomorphism in the sides and the identity in the middle, such that the diagram will commute. By HR xe small x, I will denote the moduli space of Hecke modifications on a fixed vector bundle of HR. And bar HRx small x, the set of all Hecke modifications. Here I want to maybe draw a connection between these guys. We do have here HRx small x. We're going to have here two maps to bun and x, the set of isomorphism classes of vector bundles. I'm going to call this H and H here, okay? And those things are connected by the following. I will define I'm going to send this just to E prime, and the other map just to E. Okay? And those things are connected by the following. H, R, X, E, small x is only the inverse image of, oh, here is just E, and here, minus 1 here. And it's a fact that this is isomorphic to the Grassmannian n minus R n over the residual field of the point, okay? One more thing I want to say is this set here, it will appear later on the talk. It's just, it can be seen as a set of rational points on on the Hecke stack. Okay. This appears later on this talk. Okay, so everything that I said about Hecke modifications of vector bundles for a single point can be generalized for if we change the point by an effective divisor. Everything that I said before works the same way. Okay, so I will go quickly on this slide because it's the same definitions as before, but just changing d by change x by d here. Okay. Oh, I forgot to say. Now I realized that I forgot to say that qx in the end of this exact sequence is just the skyscraper shift on the point. Sorry for that. And when you change x by d, we're gonna have the structural shift on the divisor. Okay, so this is what I want to tell about the basic concepts of Hecke modifications. And one more thing is the following: if I have a Hecke modifications, I can define a sequence of Hecke modification.
Excuse me.
Yeah.
So the multiplicity of d is so d has multiplicity at points.
Yes.
And the multiplicity corresponds to the rank of the term on the right, or not?
The multiplicity of the point in the...
What is the meaning of the multiplicity of d at a point?
will be the r, which appears here.
Okay. Thank you.
Yeah. In this slide, d is just r times x.
Okay.
Okay? So this is the generalization. And now a sequence of Hecke modifications, which I'm going to denote by this thing here, will be just a collection of vector bundles and pairwise Hecke modifications. Okay, just it. We do have a notation for the moduli space of sequence of Hecke modifications. Remark that here E is fixed, and I am collecting all E1, EL that are pairwise Hecke modifications in some points. The points doesn't need to be equal in these things. Okay, since we have a Hecke modification, we can define this sequence of Hecke modifications. Okay, now why do we care about these Hecke modifications? My background is originally from number theory, and I learned to see these Hecke modifications in the point of view of the description of the action of Hecke operators in the space of automorphic forms. So I want to go through this because there is no sense for this conference, but I want to say that it plays a key role if we're going to work on this stuff of geometric Lagrange program, more precisely the description of, as I said, the description of the action of Hecke operators on the space of automorphic forms. But these Hecke modifications also appears in other contexts, as I have some examples here. In Victoria Hill and Frank Loray, it appears as when they are studying vector bundles with logarithmic connections. So this is an example of Hecke modifications on complex geometry. One more example is the work of Araújo, Fassarella, Carr, and Massarenti, where they apply Hecke modifications to study the automorphism group of the moduli space of parabolic bundles. And one more example is this article of David Buser, where he also applies Hecke modifications for genus 0 and 1 curves to study the moduli space of parabolic bundles. And here I can just make a pause and maybe explain what I'm doing here, because I'm not a foliation guy, right? So I knew these two works you see is the almost same time, or it's the same time actually. And I realized that what I learned in my PhD thesis, which was this thing about Hecke modifications, had applications not only in number theory, but in algebraic geometry in general. And I also saw this paper of Carolina Araújo, Thiago Fassarella, Inderkau, and Alex Massarenti, which they also use these Hecke modifications on parabolic things. And then I knew in there, oops, no, back. I knew in there, and I tell her, sorry, okay, I know a little bit about Hecke modifications, you know parabolic bundles, let's try to see if you can do something from this connection. And turns out that our first ideas, we split in two projects. One of them we are developing with Frank. Winder told about that on Monday. And the other one is this connection with quasi-parabolic structure that I will tell you right now. So, okay, so this is a little bit about the context of work and why you should care about these Hecke modifications. Okay, on the other side, we have quasi-parabolic structures on vector bundle. I'm going to go very quickly because I think most of you know what's quasi-parabolic structure on a vector bundle. If you take a reduced divisor, you look by the fibers in the vector bundle, just choose a flag of vector space, and then we do have a quasi-parabolic structure on D. Okay, so start with D, a reduced divisor on X, the curve, and for each point on the support of E, support of S, we have a flag of vector spaces over the residual field of the point. Okay. One notation for the set of quasi-parabolic structures on the vector bundle. Okay. Center on the divisor D. And okay, so let me go through and try to explain how can we go from one thing to another thing. So for rank 2, this is, I think this is well known for experts on the area. I will try to explain to you now. And then ask the questions, how we go from one of our main questions is how can we go from these rank 2 connections to higher rank connections, higher rank vector bundles, I mean. So for rank 2, this is very kind of natural because if you take a Hecke modification, you have an exact sequence like that. We can go to the stocks, okay, and tensor by the residual field of the point. And then by, if you look by the dimension, here's dimension 2, dimension 1, the image of this map has to be dimension 1. And then we have a line on the fiber of the point. So we have a quasi-parabolic structure on the vector bundle. On the other side, it's not too difficult as well. Given a flag on the fiber of the point, we can just define the vector bundle, which has the same sections as our original vector bundle, with just a one slice modification. If we take a section in an open set of X such that the point is on this open, we're going to ask by the section B on the line given by the flag. Okay? And then just an exercise show that E prime is actually a Hecke modification of E. Okay? So in this way, we do have this correspondence between Hecke modification and quasi-parabolic structure of a vector bundle. And then we start to ask ourselves, and this is what I want to tell you right now. how can we go from this rank 2 correspondence to higher rank correspondence? Okay. What's the problem for, let me pose here the questions that we make to ourselves, go to higher rank and number of points, because that previous construction I did for just 1 point and any configuration of flag, okay? What's the problem? The problem is that if we do have like, let's say, several Hecke modifications of different weights in a fixed vector bundle, how can I guarantee that the correspondence vector spaces will be in a flag? This is one of the problems that we have when we go to higher rank. Because for rank 2, there is no this problem. Just have a line, just a choice of line. There is no flag, actually flag to construct. But for higher rank, this is one of the problems that we do have. Okay, so, and then this is, so the first part we have made some progress recently. And then the other problem is once we have this connection between Hecke modifications and parabolic, quasi-parabolic structure, can we say something about each of the sides using the tools from the other side? So what I have to tell you is about this higher rank correspondence for today is this theorem with Indercar from Glasgow, which is also here, and with Leonardo Mosso from University of São Paulo, from USP. We were able to prove the following. If I take a divisor on the curve, reduced divisor, okay, we can show that there is a correspondence between flags on the vector bundle center on D and sequence of simultaneous Hecke modifications on the vector bundle. Okay, so the first, the two first problems here is solved by this theorem. Okay. Just 2 words about the proof. It's very important here to have this. It's not any sequence of Hecke modifications. We have to put here E minus D. This is very important to control that we're going to have a flag when we come back from the Hecke modifications to the quasi-parabolic structure.
So why do you denote the maps morphed by D?
No, it's not a notation by the maps. It's a notation for the Hecke modification.
But it's the same. It's not the divisor. It's not the same V. Different V.
No, it's the same V.
Oh, it's different.
Look, the first slides. Sorry. I should have put more energy here. When I have a Hecke modification in a single point, I put this small x here. When I have a Hecke modification on a divisor, I put this divisor here. Okay, this is just a matter of notation. Oops. Okay.
But this D does not determine the Hecke modification, nor that these are the same, right?
This is the same, yes. What I am telling you is the following.
There is this last banyan that you add.
So D does not determine the
D
form.
does not determine. The position of the point does not determine the Hecke modification.
You mean if the order are important or not?
Just at one point, you have several choices of different flags.
Yes,
right?
yes, we do.
You have the choice of the position of the kernel in the fiber.
Yeah.
And you are denoting all these possible choices by one letter. I'm just trying to understand.
Yeah, let's see if I can answer your question. What I mean by look for, just for these first 2 guys here, I'm saying that there is an injective map between E1 and E, which is isomorphism outside of the points in the divisor. And in the divisor, close to each point, I have a skyscraper shift on the point. Okay? And all of these Hecke modifications in this sequence will give you a different quasi-parabolic structure on the vector bundle, with the condition that you have to require that the last guy is E minus D. Is the trivial Hecke modification in the end. Okay? Otherwise, we don't have a flag when you go back. Okay. So once we have done this correspondence for higher rank, we know that for parabolic theory, we do have a moduli space. We know how is the condition of stability. But in the Hecke side, we do not have this notion of stability. We couldn't compare the moduli spaces, for example. But we do have in the Hecke side what is called a Hecke stack. So our approach was, so let's see the Hecke stack, let's see the parabolic stack, and see how can we compare both of them, okay? And this is what I want to finish the talk telling. So first, I'm gonna follow Geist-Gorey and define the Hecke stack, which is the following. We have to fix two parameters, L and N, and a closed point on X. Now I'm gonna back to Hecke modifications in a single point, okay? And we're gonna define the Hecke stack as a sheaf of groupoids, which sends K-scheme S to the following data, to the groupoid parameterizing by the following data. A sequence of vector bundles on X times S, and embeddings of EI in EI plus 1, with the condition that the quotient, it's a vector bundle on the point times S. Okay? Before I generalize, let me make a remark here. What happens if we change S here by the field, by K, or by spec of K? It means what are the rational points on this stack? I mean, if we put here, instead of S, spec of K, we're gonna have a sequence of vector bundles on the curve such that there are embeddings between them, and the quotient, it's a vector bundle on the point, which means it's a skyscraper shift on the point, okay? So we going back to the sequence of Hecke modifications that we had in the beginning of the talk. So rational points is that set here. Rational points on this Hecke stack is not more than what we have in the beginning of the talk. Just a matter of comments, we can generalize this definition allowing X varies in the curve, or X to be a map between S, from S to X, and ask for the quotient be a bundle on the graph of this map. And another more general definition, instead of take one single map, take L maps from S to X and ask for each quotient here be a vector bundle on the graph of the correspondent morphism. Okay, so this is the definition of Hecke stack. And on the other hand, we have the parabolic stack, which is the following. We have to take a collection of points or a reduced divisor on the curve, a sequence of lengths, this will be clear in a moment. A sequence of lengths and a sequence of will be a sequence of ranks, such that we have the following. So you don't need to memorize all of these conditions here. It will be clear when I define the parabolic stack here. So it will be the sheaf of groupoids, which sends a K-scheme S to the following. Just one vector bundle on X times S. And for each point in this collection here, a filtration, a flag of vector bundles on the small xi times S, such that the rank of these guys here are pre-described by this vector of ranks here. Okay, this is the definition of the parabolic stack. Take a K-scheme S, send to a vector bundle, and to a collection of flag of vector bundles for each point on the curve. So if we're going back to our first theorem, what we have as a corollarium, we have a correspondence between the rational points on the Hecke stack with the rational points on this I forgot to say, but the same thing that I said about the Hecke stack. If we put in the place of S the spec of K, we're going to have a vector bundle on X and just a flag of vector spaces on the fiber of the point. So we're going back to quasi-parabolic structure on the vector bundle, okay? Because of that, we have this corollarium, which says that we have this correspondence between the set of rational points in these two, in the Hecke stack and in the parabolic stack. Okay? So to finish, yeah.
Here, the vector bundle is not fixed. So in the family, in the stack, you have a family of vector bundle and with a family of parabolic structure or Hecke modification. That's it?
Yes, but in the two sides, the vector bundles are not fixed anymore.
Yes, okay.
Yeah? Okay, so to finish, we have this, there is no a correspondence, but we do have a natural transformation between these two stacks, which is given by the following. For each K-scheme S, we're going to have eta S from the parabolic stack, or for the groupoid of associate to S to the groupoid associate to the groupoid of parabolic stack associate to S to the groupoid of Hecke from the Hecke stack associate to S, which works in the following way. What we have from the parabolic side? From the parabolic side, we have the following. We have for each K-scheme S, a vector bundle, and a filtration of vector bundles for each point. Okay? I have to tell you from where these guys go on the groupoid parameterized by the Hecke stack, which is the following. We have a sequence of vector bundles on S times X, and the question is, who are these vector bundles? Well, the first one, the last one, EL, is just the vector bundle that we have before, is E. Okay? And the other ones, the construction is very similar that we make for the rank 2 case. We construct the vector bundles EIs by the following way. For each open set on the X times S, will be the vector bundles whose sections are on E, and such that if small x times S is in the open set, we require that the restriction of the section is in the filtration given by the parabolic groupoid on X. So in this way, we and of course the inclusion is just given by the inclusion given by the construction of these vector bundles here. Okay, all of them will be sections on E with some restriction based on the filtration. Okay, so this is the construction which goes from the parabolic stack to the Hecke stack. And I think I finished. I'm so feliz aniversário, Frank, once again, and thank you.